Okay, so this is the mock foundation question number 7. In 2003, over 3,000 people were killed and 33,000 seriously injured in collisions on Britain's roads. The chances of a pedestrian surviving a collision depends upon how fast the vehicle is travelling. This is shown on the graph. On the bottom, we've got increasing speed of the vehicles from 10 to 50 miles per hour, and up the side, this is the chance of survival. So 100% chance is you will survive, 0% chance you sadly will be killed. So give a reason why some people think there should be a 20 mile per hour speed limit outside schools instead of the present limit of 30 miles per hour. So we need to refer to the graph, and we can see that at 30 miles an hour, there is an 80% chance of survival, which is quite good. However, at 20 miles per hour, there is a 96% chance of survival, which if out of 100 people is 16 more people who will survive. Okay, so right, there is a 96% chance of surviving a 20 mile per hour crash compared to 80% at 30 miles per hour. Okay. Question B says, speed cameras have been placed around Britain to encourage drivers to stay within the speed limit to reduce the number of deaths and serious injuries. The photograph shows a car passing a camera in a 30 mile an hour speed limit area. And we can see these marks on the road. Okay, a speed camera detects a speeding car and takes 2 photographs. The white road markings are painted 1.5 meters apart. From the first to the second photograph, the car has moved forward 5 spaces. Calculate the distance travelled by the car in the time it took to take the 2 photographs. Okay, so we've got each space is 1.5 meters apart, and there are 5 of them. So 1.5 meters times 5 is 7.5 meters. So the car has travelled 7.5 meters. Okay. In part 2, it tells us that the second photograph is taken 0.5 seconds after the first one. So write down in words an equation as it appears on page 2 and use it to find the speed of the car. Okay, so if we refer back to our page 2, first page of the exam, then we can see that a suitable equation would be this one here, that speed is distance divided by time. Okay, so if we go back to our question. So our equation is going to be speed equals distance divided by time. Okay, and then to use the information in the question, the calculation, we know that the car has travelled 7.5 meters, okay, from the first part of the question. That's the distance. And we know from the question here that it took 0.5 seconds to travel that distance. Okay, and if we use the calculator, we will discover that 7.5 meters divided by 0.5 seconds is 15 meters per second. Okay, now the next part of the question, it says use information in the table to estimate the speed of the car in miles per hour. So the car is doing 15 miles per hour, 15 meters per second, and 15 meters per second doesn't appear on the table, but 13.5 to 18 does. So the value is going to be somewhere between 30 and 40, but obviously it's going to be sort of in the middle. So any answer between 32 and 36 would be acceptable. So 32 to 36 miles per hour would be an acceptable answer there. Okay, because of the slight uncertainty in the table. It says here, if the car hits a pedestrian at this speed, what is the percentage chance of the pedestrian surviving? Okay, So depending upon what value you put there, okay, so 32 to 36, we take our 32, which is there. If we transfer that across to the percentage chance of surviving, which is here, and then 36, which is 36 is there, so that your value will depend upon your answer you gave in the first part. And that is pretty much exactly 40%, okay? So between 40 and 72% chance of survival, depending on what you got for the previous question. Okay, so 40 to 72% chance of survival. Okay,